Hyperaccumulator plants, nature's metal concentrators. Hyperaccumulator plants are remarkable botanical species that possess an extraordinary ability to accumulate exceptionally high concentrations of certain elements within their biomass. These elements can include metals such as nickel, cobalt, copper, zinc, manganese, lead, and cadmium. The phenomenon of hyperaccumulation has significant implications for sustainable mining practices and ecological restoration. In the 1970s, people discovered a magical tree on a small island in the Pacific Ocean. When its bark is cut open, a juice with a color like turquoise will flow out of it. Scientists have discovered that this juice contains up to 25% nickel, which they believe may be a strategy used by plants to resist insect invasion. It is difficult for ordinary plants to survive in areas with excessive levels of heavy metals such as nickel, let alone accumulate them in their own body tissues. And this plant can absorb metals that are toxic to most other plants into its own trunk, leaves, and even seeds. The organization contains a large amount of nickel compounds, which give the sap of trees a turquoise-like color. For most plants, metal elements are mainly enriched in their roots. However, in hyperaccumulating plants, the metal concentration in the leaves is abnormally high, while in the roots it is much lower. Scientists believe that this is because they transfer metal elements from the roots to the leaves in some way, thereby protecting the roots from the toxicity of metals. However, when absorbing heavy metals, plants cannot further decompose them. It is precisely this characteristic that gives hyperaccumulating plants another employment direction, to become miners. Simply put, plant mining is the process of harvesting plants after they have matured, followed by drying, incineration, and processing to recover the target metal. Some scientists believe that plant mining can accumulate nickel at concentrations several orders of magnitude higher than in soil, with much fewer impurities. Plant mining also causes less environmental damage than traditional mining, and with the ability to repair metal-contaminated soil, this mining method has a promising future. The process of cultivating, harvesting, and processing metal-rich biomass from hyperaccumulator plants is known as agromining. Agromining provides a unique opportunity to naturally extract metals from ultramafic soils, which are typically low in nutrients but rich in metals. Benefits of hyperaccumulator plants. Enhanced metal recovery. Hyperaccumulators biochemically concentrate and purify metals from the soil. This natural ability can significantly improve metal productivity per unit of biodiversity loss. Soil remediation. These plants can remediate contaminated soils and wastes, making them suitable for a wider range of metal-sensitive plants. Reduced erosion. Hyperaccumulator plants help prevent soil erosion in mined-out areas. Biodiversity conservation. Agromining can create a sustainable vegetation cover with biodiversity values, contributing to ecosystem health. The use of metal-enriched biomass from agromining to derive metal salts, such as Ni, Mn, and Zn, using green technology offers a sustainable alternative to conventional mineral extraction methods. By incorporating hyperaccumulator plants into mine rehabilitation, we can create a win-win situation for both mining companies and the environment. Hyperaccumulator plants hold immense potential as miners, contributing to efficient metal recovery, ecological restoration, and sustainable mining practices. As we continue to explore their unique properties, we pave the way for a greener and more responsible mining industry.